So today we're going to be looking at this problem. In a manufacturing company, the required torque for tightening a bolt has been checked by 5 different quality inspectors, each using 2 different kinds of torque wrenches. The results were as followed. Manufacturing management wants to know if there is a significant difference between the torque wrenches. Answer this question by writing a hypothesis test. So first, by looking at this problem, I know that it is a paired t-test because we're comparing 2 population means between 2 samples when one sample could be paired with observations of another. What a t-test essentially does, it determines if there is a significant difference between the 2 sets of observation. So first, let's just write out our hypothesis. So our first one is the significance is 0. And then our other hypothesis will be that there are not equal to 0. Okay, next we should write out our t-statistics formula so then we can figure out what we need for the formula to eventually find if there is a significant difference between torque wrenches. So is the mean difference minus 0, because we have 0 here in our hypothesis, that's what we want, divided by SE. Okay, so next, in order to get our mean of D, we need to find the difference between torque 1 and torque 2. So we'll do this by torque 2 minus torque 1. So for the first one, we'll get -1, -2, -2, 0, and 0. Okay. Now, since we know our differences, we will add all of these values together and divide by the number of inspectors to get our mean of D. So that will give us -5 divided by 5, which equals 1. Okay, for our mean of D. Next, we need to find our standard deviation of the change in D. So we will do this by the square root of each of the differences minus our -1. So it will be -1 plus 1 squared plus -2 plus 1 plus 0 plus 1 squared plus 0 plus 1 squared. Now all of this will be put in brackets because it's that divided by 4 as well inside of the square root. And that will equal square root of 4 divided by 4, and that will equal 1. So now we can find our SE, and our SE is our SD divided by our number of inspectors, all under square root. So it would equal 1 divided by square root of 5. Okay, and that is about 0.4472. Okay, so now we have all our information to find our t-statistic. So now we'll just plug it in. -1 minus 0 divided by, put this this in parentheses so you could tell better. 0.4472, and that is our T statistic. Okay, then from this will equal negative 2.23606 about. Now, so when we determine whether to reject or fail to reject our hypothesis, we need to find our t-value according to the significance level that we are given. So t, since this is a two-sided, this 0.05 will be 0.025 because it's two-sided, and our degrees freedom will equal 4 because our degrees freedom is n minus 1 and 5 minus 1 equals 4. So then we're going to look this up on our t score sheet. So let me pull that up. Okay, so if we look at our t score sheet, 0.25 and our degrees freedom, 4, we get 0.741. Okay, so I'll write that in on our other sheet. We get 0.741. So now if our t star, which I'm going to say is what we found from the graph, I'll put t star right here. If our t star is greater than our t statistic, then we fail to reject HO. Likewise, if our t star is less than t statistic, then we reject. Now, in this example, our t star is 0.741 is greater than our t statistic of negative 2.23606. So, since our t star is greater than our t statistic, then we fail to reject HO. So now let's summarize this in a nice sentence. There is no substantial evidence to support a significant difference between the torque wrenches. Okay. So you show that there is, so you rejected HO, so you showed that there is a difference between torque wrenches 2 and torque wrenches 1. Okay, so that's really it.